Hello and welcome. In this video, I'm going to show you how to do an example similar to the one for your homework. And in the scenario here, we have a certain species of fish in the lake. It has a population of 1,000. Now, under optimal conditions, this population is going to triple every 13 years. And we need to begin by first figuring out what the value of k is in this scenario. So the formula here to figure out k is to get the natural log of the amount that we want to get to, which in this case is in 13 years, the amount in 13 years divided by the amount that we're initially going to start and dividing it by the time, which in this case is going to be 13 years. So we're starting off with 1,000 fish and it's going to triple. So in 13 years, the amount of fish that we're going to have is going to be 3,000. So since we're dividing that amount, this amount here, by this amount right there, that's going to end up simplifying to 3. So we can just simply get 3,000 divided by 1,000 and divide that by 13 years. So we're just essentially getting the natural log of 13. And then that number gets divided by 13. I'm sorry, getting the natural log of 3, not 13. Getting the natural log of 3 and that answer being divided by 13. So to type this into decimals, we're going to start with clicking divide. We're going to now type in the natural log, and inside there again we're dividing 3,000 by 1,000 like I mentioned earlier is 3. So the whole triple thing kind of gives it away what the value of that we're going to divide. We're going to get the natural log of. So the natural log of 3, and that's going to be divided by 13 years since it takes 13 years to triple. So our estimated value of this number here, put a comma, paste that into 3 decimal places, is 0.085. So with 0.085, we now have the model. So what's this? The population. So we'll call it P. P of T is going to start off with 1,000 fish. E raised to the 0.085. And it makes sense that it will be a positive number since it's tripling. So that value is increasing over an increment of T years. Now using this model for part C, we're just going to evaluate it at 28 years. We're going to estimate the population after 28 years. So starting off with 1,000 fish, it increasing in an exponential rate of 0.085. We're going to replace T with 28. So here our answer is 10,804.9, so 0.5. Estimated at 0 places, that's 10,805 fish. So here are the answers for each part. And lastly, we can now do part D. So we're going to use again the model from part B, the 1,000e to the 0.085t. And we're going to now set that equal to 17,993 fish. And the reason we're doing that is because we need to determine the time. So we don't know what t is, but we know that the amount is going to equal to that value. So if I set the model right here and set it equal to that, I know that there is at some time my population has to be 17,993. So I'm going to replace this with that number there, as you see right there. I just wrote it backwards. I have this over here, P of T, like this. And I'm replacing that with this number there. So I need to solve this equation. And I do that by first starting by dividing by 1,000. And I'm not going to divide it, at least just yet. I'm not going to plug it into decimals, but I'm going to leave it just as this ratio. I'm going to take the natural log of both sides, take the natural log of this, and 0.085t equals the natural log of my 17,993 divided by the original value of 1,000, and then dividing that number by 0.085. So we get that t equals to the natural log of this ratio of the amount that I want to get to divided by the amount that I want, the natural log of that ratio, and then that value divided by the k value. So the only thing left is to plug it into decimal and see what the decimal value of that. So we start with dividing the natural log, again, of 17,993. That value gets divided by 1,000. And then moving your cursor down, we're going to divide that number there by that value of k, which is 0.085. So 61.0, so 61 hours or years or whatever the unit measurement. So here you have your answer for part D. 61.08 is acceptable. You could just estimate it to 61 years. So it's going to take 61 years to get from 1,000 to 17,993 fish. So I hope this video was helpful. If you do have any questions, again, send me a message through email or message the instructor, and I'll get back to you as soon as I can. I appreciate you watching, and I hope you have a good day.